What exactly is a server? Is it some mysterious, ultra-powerful machine hidden deep inside a high-security facility? Or is it something much simpler than most people imagine? At its core, a server is not as complicated as it sounds. In fact, the idea behind it is surprisingly straightforward. A server is simply a computer that provides something, data, services, or resources, to other computers. That's all there is to it, at the most basic level. But if the concept is so simple, why does it power nearly everything we do online? And how did such a simple idea become the backbone of the modern internet? To understand servers properly, it helps to start with how computers communicate. Whenever you open a website, send a message, stream a video, or even scroll through social media, your device is not working alone. It is constantly asking other computers for information. Those computers that respond to these requests are what we call servers. Think about the last time you visited a website. You typed a URL or clicked a link, and within seconds, the page appeared. But where did that page come from? It didn't magically exist inside your device. Instead, your browser sent a request across the internet to another computer, a server, that stores the website's files. That server then sent those files back to your device so your browser could display them. All of this happens in milliseconds, often without you even realizing it. This is where the idea of different types of servers comes in. Not all servers do the same job. Some are designed to deliver websites, others to store and manage data, and some to handle files or applications. A web server, for example, is responsible for delivering web pages to users. When you visit a site, you're essentially asking a web server to send you the content needed to display that page. But what happens behind the scenes when you log into an app or search for something? Where does your data go? This is where database servers play a crucial role. These servers are designed to store, organize, and retrieve data efficiently. Every time you log in, your credentials are checked against a database server. Every time you like a post or save a file, that information is stored somewhere, and that somewhere is typically a database server. Then, there are file servers, which are used to store and manage files. These are common in workplaces where multiple people need access to shared documents. Instead of sending files back and forth, everyone can access them from a central server. It simplifies collaboration and ensures that everyone is working with the latest version of a file. At this point, you might be wondering, are servers just regular computers? The answer is both yes and no. Technically, any computer can act as a server if it is configured to provide services to other computers. However, dedicated servers are often built with more powerful hardware, better reliability, and the ability to run continuously without interruption. After all, imagine if a major website went offline just because someone turned off a machine. But here's where things start to get even more interesting. In the past, servers were almost always physical machines. Companies would own large data centers filled with rows and rows of hardware, each machine performing specific tasks. These data centers required significant investment, maintenance, cooling systems, and physical space. So what changed? Why don't we hear as much about physical servers anymore? The answer lies in virtualization and cloud computing. Instead of relying on a single physical machine for each task, modern systems can create multiple virtual servers on a single piece of hardware. These virtual machines behave like independent computers, each with its own operating system and resources, even though they are running on the same physical machine. This shift has transformed how businesses and developers think about servers. Instead of buying and maintaining hardware, they can rent virtual servers in the cloud. This means they can scale their resources up or down depending on demand. Need more power during peak hours? Add more servers. Traffic drops? Reduce them and save costs. This brings up an important question. What does scaling really mean, and why is it so important? Imagine running a website that suddenly goes viral. One moment, you have a few hundred visitors. The next, you have millions. If you relied on a single server, it would likely become overwhelmed, leading to slow performance or even crashes. This is where scaling comes into play. Scaling allows systems to handle increased demand by distributing the workload across multiple servers. Instead of one machine doing everything, hundreds or even thousands of servers can work together to handle requests. This not only improves performance, but also increases reliability. If one server fails, others can take over, ensuring that the service remains available. Have you ever wondered how streaming platforms manage to deliver videos to millions of users at the same time without constant buffering? The answer lies in this distributed approach. content is stored across multiple servers located in different parts of the world. When you hit play, your request is routed to the nearest or least busy server, reducing latency and improving speed. But scaling isn't just about handling large numbers of users. It's also about flexibility and resilience. Modern systems are designed to adapt in real time. Servers can be added automatically when demand increases and removed when they are no longer needed. This dynamic behavior is one of the key reasons why cloud computing has become so dominant. Another important aspect to consider is reliability. What happens if a server goes down? In a well-designed system, it doesn't matter much. Redundancy ensures that multiple servers can perform the same task. If one fails, others step in seamlessly. This is why major online platforms can maintain high uptime, even in the face of hardware failures or unexpected spikes in traffic. Security is another layer that adds complexity to servers. Since servers often store sensitive data and handle critical operations, they need to be protected from unauthorized access and attacks. This involves encryption, firewalls, monitoring systems, and constant updates. So while the basic idea of a server is simple, maintaining one securely is a much more involved process. So where does all of this leave us? If a server is just a computer that provides services, why does it feel like such a powerful concept? Perhaps it's because servers are the invisible foundation of the digital world. Every email you send, every video you watch, every file you upload, all of it relies on servers working quietly in the background. They are the reason the internet feels seamless and instantaneous, even though countless processes are happening behind the scenes. Now consider this. What would the internet look like without servers? Could websites exist? Could apps function? Could communication happen at the scale we experience today? The answer is simple. None of it would be possible. Servers are not just part of the internet, they are the internet. And yet, despite their importance, the concept remains beautifully simple. A server is just a computer helping other computers. From that one idea, an entire ecosystem has evolved. One that powers everything from small personal blogs to global platforms serving billions of users. So the next time you open a website or stream a video, take a moment to think about what's happening behind the scenes. Which server is responding to your request? How many machines are working together to deliver that content? And how quickly is all of this happening without you even noticing? The simplicity of servers is what makes them so powerful. They remind us that even the most complex systems are often built on ideas that are easy to understand, but incredibly impactful when scaled. And maybe the most fascinating question of all is this. If such a simple concept can power the entire internet, what other simple ideas are waiting to reshape the future? Would you like it? Hit the like button and subscribe to our channels for more interesting and informative videos.